In this section, we are going to discuss about NTP or Network Time Protocol. So basically, NTP is used to maintain time across our network devices, and it is open standard. It uses UDP port number 123, both for the source and destination port. So NTP is very important in our network because whenever any event is triggered on our network devices, then we must know at what particular time that event was generated, right? Because during troubleshooting, let's say if we have some devices in our network, it is running, let's say BGP or OSPF, and whenever the BGP or OSPF it goes down, then we must know, or during the troubleshooting, we'll check the logs to find out at what time the BGP or OSPF went down, right? So for any event that is generated on the network device, we must know the time at time interval, right? So that we can troubleshoot further on that particular event. Also, there are two type of devices in NTP. We have the NTP clients. So the devices that is going to connect or that will reach out to the NTP server to ask for the time. Okay, then we have the NTP servers. So the devices that are going to provide the time for the NTP clients. Also, as I put a note here, note here that a device can work as both NTP server and client. So we'll see this in the practical also. And NTP server, they works on the Stratum number. So the Stratum number is nothing but it is used by the client. So let's say I am the client and there are multiple NTP servers in our network, and now I need to choose which NTP server I'm going to use for the time. So the Stratum number lower is better. So let's say if I have three NTP servers, one is having Stratum number 2, second one is having the Stratum number 3, and the third one is having the Stratum number 4. So the server which is having the Stratum number of 2 is going to win, and the client is going to use the time that is shared by the that particular NTP server. Okay, on Cisco devices, when we are using the Cisco devices as the NTP server, by default, if you do not provide any Stratum, so they are going to use Stratum number 8. So the range of Stratum number is from 1 to 15. All our network devices, they have the built-in internal clock. On Cisco devices, as you must be you are already aware, I think, that we can see how to check the clock on the Cisco devices. We have the command show clock, which will show us what exactly is the time that is running on that particular device. We have the Stratum 0 also. It is the Stratum number, or the 0 Stratum number is given to the super accurate time servers, like we have the atomic clocks or the GPS clocks, etc. Then we have the Stratum 1. So the devices that are directly connected to the Stratum 0 devices, that will be given the Stratum 1. So now we will see the NTP with a small practical. So we have few devices in our network. We have an NTP server. Basically, this is also a router. I just changed the image because we do not, in this particular practical, we are not going to use some real-time NTP server. I just want to demonstrate how NTP works. What are the different commands that we can run on our devices? So we have R1, R2, R3, and R4. So there is a routing protocol that is running between R1, R2, R3, and 4, which is OSPF. And IP schema is pretty simple. Between R1 and R2, we have the network of 12. Between R2 and R3, we have a network of 23. R3 and R4, we have 34. And between R1 and R4, we have a network of 14. between R1 and the NTP server, we have the network of 100. So first of all, let's go to NTP server. You can see that these are the logs, right? So whenever any event is generated, there is time in front of that particular event. So that is why the NTP is very, very important. That if time is not correct on your network devices, then it will be very difficult to troubleshoot, right? Let's say you have two devices and BGP is running between them. Let's say you have R1 and R2. So on R1, let's say you have correct time, and R2, let's say your time is half an hour ahead of that uh, of R1. So let's say your BGP went down at 9 a.m. So on router 1, because your time is correct, you will go and see, okay, at what time the BGP went down, and the log will tell you that, okay, at 9 a.m. the BGP went down. But when you go to R2, because its time is half an hour ahead, then it will show you 9:30, that at 9:30 your BGP went down. So now you can imagine that if you do not have a correct time across your network, it will be very, very difficult for you to troubleshoot, right? So I'm on the NTP server. If I do a show run pipe include NTP, right now we have one command that I previously configured on this. I'll remove this command to show you from the start. So now if I check again, there is no NTP related command, right? If I do a show NTP status, there is nothing. NTP is not enabled. If I do a show IP interface brief, I have an IP address configured here, 100.1.1.1. If I go to R1, show IP interface brief. So the interface that is connected to the NTP server, it is having an IP address of 100.1.1.2. One interface is down. Let me no shut this interface, which is connected to R2. Let's go to R2. There also one interface is down. I need to bring it up. Interface Ethernet 1/0, no shutdown. Okay. So I'll also, if I go to R1, you can see if I do a show IP OSPF neighbor, R1 is having two neighbors, which is R2 and R4. Likewise, if I go to R3, then show IP OSPF neighbors. I do have two neighbors, R2 and R4. If I do ping an IP address which is connected to, let's say, R1 and R2, I'm able to ping, right? And on the other end also 14.1.1.1. So I'm able to reach all the IP address within this particular OSPF domain. Okay, now first of all, let's go to R1 and see what is the time. First of all, let's see if there is any NTP running as of now. There is no NTP server. If I do a show clock, so the clock says that right now the time is 19:10, almost 7 p.m., right? And we have 10 minutes. If I go to the NTP server and if I check show clock, so almost same time. So let's change the time here to demonstrate. We'll say clock set, then time, let's say 20. Okay, Then we need to give either the date or the month. Let's say we'll put the date. So today is 9th 06. It is 9th of June, the month, and then we need to put the year 2024. Right? Sorry, we need to say June like this, not in numeric. So 2024. If I do a, you can also see the log message. System clock has been updated from this to this value. Okay. If I do a show clock, so on the NTP server now the time is around 8 p.m. If I go to R1, show clock, almost 7 p.m. and 12 minutes. Now let's go to the NTP server. So on the NTP server, the command that we need to run is, we'll say NTP master. If I do a question mark, either we can say enter or we can define the stratum number. Let's say I do not set the stratum, I'll just say enter. Okay. If I run this command, let's say show NTP status. Now you can see that as we discussed that on our Cisco devices, if we do not configure any stratum, by default it will take stratum 8. And you can see here the reference. Basically the reference will tell us that who is the NTP server, right? From which I am synchronizing for the time. So you can see here we do have the loopback address. So as we know that do not get confused the between the loopback address and the loopback interfaces, right? The loopback address and loopback interfaces are totally different. So this particular IP address or the subnet 127, starting with 127, it is reserved for that, for locally for that device, right? So this particular IP address is owned by this particular device only, because this is the NTP master. It is not going to ask someone for the time, right? So now let's go to our topology. So now we have the NTP server wherein we have the time almost 8 p.m. and 2 minutes, and on R1 the time is almost 7 p.m. and 14 minutes, right? Now we have configured the NTP server as a master, right? With the command NTP master. So this is the only command that we run so far. Pipe include NTP. So this is the NTP server and we have given the command NTP master, and it has already taken the default stratum value, which is 8 on our Cisco devices. So now I am on a router 1, which is the NTP client. So will try to sync the time from the NTP server on R1. Okay. So the command is NTP server. We need to tell R1 who is the NTP server. So the IP address of the NTP server is, you go show IP interface brief. Here is 100.1.1.1. That's it. If I do a show NTP status, you can see that clock is unsynchronized and stratum is 16. As you know that the value of stratum is from 1 to 15. So 16 means unreachable, or we do not have any communication with the NTP server yet. Okay. So this stratum value must be less than 16. No reference clock. So still R1 is trying to connect with the NTP server. Let's see if we have the connectivity with the NTP server. We have the connectivity. If I do a show IP interface brief, so our IP is 100.1.1.2. IP of the NTP server is 100.1.1.1. Let's try again. Show NTP status. Still it is checking. Show NTP association. show NTP status. Still it is checking. Now you can see that the stratum is updated from 16 to 9, right? Because you can see that the stratum value at NTP server is 8 and R1 is one hop away from the NTP server. So the stratum value at R1 is 9. Now if you run this command and show NTP associations, now you can see that the IP address of the NTP, and we must see the star value, which means that this particular NTP server uh, is used for the to update the time on this particular device. Okay, and the stratum value of this particular neighbor or this NTP server is 8. We have some polling interval, so the NTP client, they are keep on checking if our NTP server is live. They have some default timer, I think it's 64 seconds or something, so they'll keep on checking this. So now if I see the clock, show clock, now you can see the time of R1 is updated from 7 p.m. to 8 p.m., almost 8 p.m., right? And on Cisco devices, by default, the time is in UTC. So because I'm in the IST time zone, so I have changed it deliberately. So I will show you the command. So you can run this command to change the time zone. You will say clock, time zone, and then you need to type the name of the time zone. It is just the name. Okay, it does not mean that if I'm putting IST, so the router or this particular device knows what is the IST time zone. So this is just the keyword. Okay, so clock, time zone, IST, and then you need to give the value. For example, the IST is 5 hour and 30 minute ahead of UTC. So I'll just type 5, which is hours, and then 30 minutes. So just I will say enter, and automatically uh, the device is going to add 5 hour and 30 minutes to the default UTC time value. So that I have already done before this particular video started. So this was the configuration that we have applied on R1. Okay, now one more thing we discussed, that a device can act as both the client and the server. So for example, now we'll see that R1 is working as a NTP client, which is synchronizing with the NTP server to update its time. Now we'll see that for R2 and R4, R1 will act as a NTP server as well. So if I go to R1, I will say NTP master. I will say enter. If I say show NTP status, now I'll go to R2. Wait a minute. I'll go to R2. I'll say show run pipe include NTP. We do not have anything, and we already know what is the command. NTP server, the IP address of the NTP server is, for R2 we have a 12 network, and on R2 we have the IP address of .2, and on R1 we have .1. So 12.1.1, which will be the IP address of the NTP server or R1 for R2. Similarly, I'll go to R4 and I will say, first I will check if I have already removed the NTP configuration. There is no configuration, so I will say NTP server and then the IP address of the interface of R1, which is 14.1.1.1. Now let's say show NTP status. Now you can see the clock is synchronized. Our own stratum is 9 because the NTP server, which is R1 for us, its stratum number is 9 and we are one hop away from R1. So at R4, you can see that our stratum is 10. 9 plus 1 is equals to 10. And reference, this is the NTP server that we are synchronized with, right? 14.1.1.1, which is the IP address of the interface of R1, which is connected to R4. I can run the another command also, which is this one. And we can see we have a star value, which means that we are synchronizing with this particular device for the time. And the reference clock is this one, right? You can see that the reference clock that is used by our NTP server, which is R1, is this one, right? And the stratum value of R1 is 9 and all the other details. Now you can also see that this device is also updated with the new time, which is updated on the device, which is R1. On R2 also, if you see, if I do a show NTP status, it is also synchronized. Its stratum is also 10 and it is also getting the update from R1, which is having the IP of 12.1.1.1. You can also run the associations, and here also you'll find out about the IP address, the reference clock that our NTP server is using, the stratum number of R1, which is 9, and all the other details. Okay, now I will show you one more thing before I do this. As I mentioned that the lower stratum number is preferred, right? So for R3, let's try to make R2 and R4 as the master. And if I go to R2, I will say NTP master and I will give a stratum of, let's say, 13, right? Now I will go to R4. I will say NTP master. I'll give a higher stratum number, which is 14. Now I will go to R3. First of all, I will check if there is any NTP related configuration. NTP. I do not have any configuration. Now I'll say NTP server. I have two servers, right? One is R2, which is having this IP address. And then I will have another NTP server, which is R4, which is having this IP address. Now we will see that because R4 is having the stratum number of 14 and R2 is having the stratum number of 13, that is why R3 is going to update the time from R2 only, okay? Or it will prefer R2 over R4 because it is having the lower stratum number and lower stratum number is preferred. So if I go to R3, I'll say show NTP status. Now you can see that the reference it is taking, the clock is synchronized and this is the IP address of R2, right? Now also if you do this command, you can see that we have two NTP servers, right? 23.1.1.2 and we have 34.1.1.4, and the one which is having this star value, it is the one that our device is preferring for the time updation, right? So this is also proved that the lower stratum number is preferred. Now one more thing I will show you. If I go to our diagram, if I go on R3, there is one more command that I wanted to show you. If I do show running configuration pipe including NTP, so if you bypass this Stratum condition and you want some particular NTP server I mean, if you have multiple NTP server and you always want to choose one of them, if it is live, then make sure that your device is going to sync with that only. So for example, I want R3 to always prefer R4. Okay, till the time R4 is live, R3 must synchronize with this device only or R4 only. So what we can do with this command, NTP server and the server IP, you can say prefer. Okay. So in the next NTP update, if you check this one, okay, you can see that this timer is increasing. Okay, as soon as we get a new update, you will see that the star value will be shifted from R2 to R4 because now we have done this. We have used the keyword that prefer this particular NTP server. Okay, so we'll wait for the timer to expire. We'll wait for, in fact, we'll wait for R4 to send the next update. We still have the timer running for R4. 54, 5, 6. It is increasing. Let's wait for R2 also. Its timer is also going to expire and a new update will be sent. So far it is not synchronized. Show NTP association. So it is not synchronized. Maybe in your production environment it will be much faster. What I can do, I will remove the configuration and then I'll put it back. Okay, to show NTP association. Still it is not updated, so I will remove no NTP server 23.1.1.2, no NTP server 34.1.1.4. prefer. Now there is no NTP server. Show running pipe include NTP. If I do an NTP server 34.1.1.4 prefer and 23.1.1.2. Now you can see that though on R2 we have a lower stratum number which is 13, right? And on R4 we have a higher stratum number still because we have the prefer command configured on R3. It is going to prefer R4 over R2. If I do a association command again, now you can see that even though the we have the lower stratum number configured on R2, right? Still it is preferring 34, right? So that is how NTP works. If I do a show NTP status. Now you can see that we are synchronizing our clock with R4. So the last thing that I'm going to show you is, let's on R2, what I will do, I will shut down the link between R1 and R2. Ethernet 1/0 shutdown. R1 also Ethernet 1/1, which is connected to R2. I'll do a shutdown. Now, if I go to R2 and if I say show NTP status, still it is synchronizing, but let's wait. Show, if I try to ping, now we are not able to ping our NTP server, right? You can see I'm not able to ping the NTP server which is configured on R2, which is R1, right? If I do a show run pipe include NTP, so if I do a show NTP associations, now you can see that the star value is with the local address and R2 is considering the local time because the NTP server is not reachable anymore, right? So that's the problem because this particular link is down and our NTP is not reachable anymore. So that is why what we have to do, always try to use the source for the NTP as loopback. So for example, I'll show you for maybe R4 and, or let's make this link up again and then I'll show you. I'll say no shut on R2 and on R1 also I will say no shut. I'll go to R2. I'll say again same command to check. We'll wait for NTP to sync again. We are able to ping the NTP server. Okay. So it will sync sometime. Just wait. Meanwhile, it is getting synced. What we can do, we can create one loopback address. Okay, let's say on R2, I'm creating a loopback address of, let's say 2.2.2. IP address is 222.255.255.255.255 and IP OSPF1 area 0. I'm also advertising this into OSPF. And on R1 also interface loopback 0, IP address 1111.255.255.255.255, IP OSPF1 area 0. And let's go to R4 also. Interface loopback 0, IP address 4444.255.255.255.255, IP OSPF1 area 0. If I go to R1, you can see show IP route OSPF. You can see I'm learning 2.2 and force loopback as well, right? If I go to R2, now you can see the star value is moved from the local clock to R1, right? Because R1 is back. Now, if I again shut the link, before I shut the link, what we have to do, we'll say NTP source is loopback 0. That for the NTP, when it is sending the communication to the NTP server, it is going to use the loopback address instead of the exit interface IP. Okay, so we'll configure this command on all devices, NTP source, loopback 0. Now let's try to shut again the link. So I will go here, I will say shutdown. On R1 also, I will say, sorry, shutdown, show IP OSPF, show IP OSPF neighbor. There is no neighborship with R2. If I do show IP route OSPF, but still I'm learning the loopback of R2 via R4, right? So if I do a ping to the NTP client, which is R2, having a source of loopback 0, so I'm able to reach to R2, which is the NTP client, right? If I go to R2, can see there is no neighborship. But if I do a show NTP status, show NTP association, so now the problem is because in the configuration we did not change NTP, the IP, we have to change the IP address also of our NTP server, right? So let's do this. Let's unshut it again. No shut. We have to change the IP address also, right? Because for R1 now the IP address is 1.1.1.1. So we will no shut this also, and we will wait for R2 to use the clock of, or else what we can do, we'll say show run pipe include NTP. I will remove this and I will say NTP server is 1.1.1, right? This is the R1 loopback IP. If I do a show NTP status, let's wait. Now you can see the clock is synchronized and with the new IP, which is the loopback IP of R1. And if I do this command also, you can see that we are synced with router 1 loopback IP. The reference clock is the clock that R1 is using, which is the NTP server IP, and the Stratum value and everything. So now let's try, first of all, show run pipe include NTP. And so R1 is the NTP master. It is also using the source as loopback 0. Now let's try to shut again. So I'll shut the interface again. And here also I will do a shutdown. Show IP OSPF neighbor. There is no neighborship between R1 and R2. But if I do a show IP route OSPF, we are learning the IP address of R1 via R3. And similarly on R1, I'm learning the IP address of the client, which is R2 via R4. I can also test the ping response. Now if I go to R2, show NTP associations, now you can see that there is no change in the clock, right? If you do a show NTP status, we are still synchronized. Why? Because we are using the loopback IP, though the interface between R1 and R2 is down, but we are able to reach the NTP server via this path, via R3, R4, and then back to R1, right? So this was all about NTP. So as you know that we do not have much configuration, it's pretty simple. So this is how we can configure NTP on our Cisco devices. I hope you like this video, and thanks for watching.